Hi, good morning, everyone. So, welcome to today's TensorFlow workshop. So, my name is Nur Fatiha binti Abdullah, but you guys can call me Fatiha. So, I'll be your MC for today and your host for today. So, a very good morning. We're very thrilled to have all of you here as we dive into the exciting world of TensorFlow and neural networks. So, today's workshop is designed to help you gain hands-on experience with TensorFlow, from the basics of neural networks to practical and hands-on um, topics. So whether you're a beginner or someone with a prior experience, there's something here for everyone. So before we jump into the workshop, I would like to share a moment to share something exciting with all of you guys. So speaking of exciting opportunities, I am thrilled that Kita Hack 2025 is just around the corner. So Kita Hack is one of the largest hackathons in the regions, bringing together innovators, developers, and problem solvers to create groundbreaking solutions. So this is your chance to collaborate with like-minded individuals, learn from industry experts, and also showcase your skills. So whether you're into AI, web development, IoT, or anything in between, Kita Hack 2025 has something for you. So the best part is registration is now open. So if you're still interested, all you need to do is scan the QR code on the screen that I'm sharing right now, and just registered. Okay, so don't miss out on this incredible opportunity to be part of something big. Okay, so let's get back to today's agenda. You guys can take a screenshot or maybe take the pictures of these QR first and then register later. So let's get back to today's agenda. We have an action-packed schedule lined up for you, covering four key modules, which are the first one is Introduction to Neural Networks. The second one is Introduction to TensorFlow and image recognition, and then the last one is image classification with CNN. So now, without further ado, let's welcome our speaker, which is Ayman Hakimi. He's from GDG OCIIUM and currently is the lead for the AI and machine learning department. So let's give him a warm round of applause. So, Ayman, the floor is all yours.
All right. Thank you, Fatiha. All right. So I guess so. There is nothing else. So we can start our workshop for we can start our workshop. So let us start with module number one, which is introduction to neural networks. So before I formally start, I would like to give a kind of a disclaimer that this is intended for more towards introductory and beginner levels. But don't worry, even if you have experience, you can still join to, you can still stay here. You can have, in case there's something else that you've learned for today. So basically, this workshop is intended for introductory and beginner levels towards neural networks. All right, so before I start, I want to ask I want to ask generally, how familiar are you guys with the term? So, is anyone here with familiar with the term machine learning? So, so basically, what machine learning is a subset of AI, a subset of AI. So, think machine learning is like there's a set of AI. AI is like the big picture here. And then within AI, there is what we call as machine learning. So machine learning is kind of like, imagine if you program something, you must know what the input is, and you pass it into a process, into some kind of processing or some kind of function, and you expect a certain output. So in normal programming, you determine like what the function is, and you give it an input and it will give an output. For like for example, if you have like a function that adds two numbers like a and b, so the input would be a and b, like 2 and 3, and then the output is 5. That is like um, normal like programming. But for machine learning, it is different, because for machine learning what we are trying to achieve is we have a input and we have an output, but we do not have this function. This function is determined by by the AI. Function is unknown. So what machine learning actually wants to achieve is that is to determine what kind of function, so that a particular input will give out a particular output. So that is basically what machine learning is. So so machine learning so in so machine learning, there's essentially three paradigms for learning, meaning that there are like three ways a computer or an AI can learn. The first one is supervised. We'll get that into a minute. And then there's the unsupervised. And lastly, there is reinforcement. So what is the difference between these three? So for this workshop, I would like to touch on the supervised learning. So unsupervised and reinforcement, we will not touch within this workshop, but I will give you a simplified definition. So supervised learning is a kind of machine learning where you have an input and then you have an output. So this is like the most common type of learning. So you may sometimes hear that an AI needs a lot of training data, needs to train based on a lot of data. So that is what supervised learning means. You give in, for example, you give an input of like images of cats and dogs, and the outputs will be either cat or dog. So that is what supervised learning. You give it an input and you give the output, so it will figure out what functions it needs to return. So for unsupervised is kind of like supervised learning, but the difference is both the functions and the outputs are unknown. So essentially, you only have the inputs. Okay, so so a key takeaway for supervised and unsupervised, supervised learning can actually predict. For example, so if you have like I said, you have two images of a cat and a dog. So for using supervised learning, it can classify one as a cat and one as a dog. So how about unsupervised learning? Unsupervised learning, they are not capable of recognition, but they are capable of classification. So what does that mean? So imagine I have a graph over here, and there's the data over here, the input. Imagine the input is like clustered around here, and then there's this input over here. So and then there's more inputs over here. So what unsupervised learning does is basically it finds patterns. So unsupervised, so it for unsupervised learning, it will like kind of find this pattern over here, this pattern over here, and also this pattern over here. So unsupervised learning. All right, sorry, the audio is a bit muffled. All right, I'm sorry for that. Okay, so let me repeat. So unsupervised learning, you have an input, but you do not have an output. The use for unsupervised learning is to find like hidden patterns, or to group hidden patterns that you may not have noticed before. So it is used for pattern recognition and grouping certain classes together. So that is what unsupervised learning is for. And lastly, we have the final one, which is reinforcement learning. Reinforcement learning, which this is reinforcement learning, it is very different for supervised and unsupervised, because essentially it uses something that is called an agent. This is what, so for example, we have something called as an agent. So this agent is the AI that we want to train. So for example, an agent, and it is set up in something that we call as an environment. So an environment, for example, so if we want this agent, for example, to get towards the goal over here, so we do not determine it's what it will do. We only give it reward. So if it's closer and closer towards the goal, we will add a reward. But if it's further and further to the goal, we will give a punishment towards the agent. So this is basically what reinforcement learning is. So for the workshop today, we will focus mainly on supervised learning. So there are like kind of a few terminologies that we jump straight into the actual hands-on, because it is very good to understand first the theory behind it, so before going on the hands-on. So we are going to implement supervised learning using something that we call as using a neural network. Supervised learning using neural networks. Neural networks is neural networks, or most commonly people refer this as deep learning, is basically like a machine learning where it uses neurons or neural networks. So what does this look like? So like we have before, we have AI, and then within that there is a subset of machine learning, and then there is another subset called as deep learning or neural networks. So essentially, how does this works? So you have a neural network. A neural network consists of three kinds of layers. So there are three layers over here, and each of these block bubble looking things is we call as neurons. All right, that is what we call as a neuron. So there are three layers to here. The first layer is what we identify as an input layer, and the final layer is what we identify as an output layer. And between this there can be many, there can be one or more layers, but essentially anything between the input and output layer is what we call as the hidden layer. So these three layer works together to form a neural network. So each layer over here is connected to another layer. So this is what we call as a fully connected layer or a dense layer. So, so it's okay. So kind of like this. All right. So there is like a few terminologies to understand before we jump into the more hands-on approach. All right. So are we done yet? No, we are not done yet. There are a few things that we need to know before moving on. All right. So you can refer to the module as we speak. So now there are another terminology. So they basically, how does this work is that there is a bunch of maths. So for example, if we input it as 1 in the first neuron over here, so there we do some calculation, there will be some calculation for the weights and biases. So there's calculations, and then it will be inputted into the hidden layer. For example, this got 0. 0.5, 0. 0.1, 0. 0.2, 0.3, and then how about this 0.7, and then all of this will be connected to the last layer, the output layer, and then all of this will be calculated, and then there will be input for like this will be 0.2, how about this 0.7, this is 0.1, and then commonly the highest output is its answer, meaning so it predicted the output of 0.7 like this. So this is a very simplified version on how neural networks work. All right. So up to this point, so does anyone has any questions on how does a neural network work? All right. Okay, all good for now. So I will move on with something that is very the learning part of neural network, which is what we call as back propagation. So back propagation is basic. Okay, so I have a simple fully connected layer over here, only one neurons, two and one. So first it so for a neural network, the first step for a neural network, it will assign random weights and biases towards each of the connected networks over here. So essentially, the first cycle, it will start with random parameters. It will start with random values, and by doing back propagation, so for each iteration, it will adjust the value of the weights and biases according to what the output wanted, the actual output as wanted. So that is what we call as back propagation, and it is used very much using TensorFlow, because back propagation there are lots of algorithms for it. We have optimizers such as Adam, we have gradient descent, but I don't want to touch on that very deeply. But just know about the term back propagation. Oh no, just know about the term back propagation, because we will be referring that during our hands-on image recognition. So that is all for introduction to neural networks. So okay, before we move on to module number 2, anyone have further questions? So, first of all, I apologize if this is kind of overwhelming, but at the first time, it may seem overwhelming, especially for those who are beginners and introductory levels. But as we go on, we will further understand how the architecture is set up and how is it set up within TensorFlow. All right. So that is if that there is no questions from the audiences, I will move on towards the second part of our module, which is introduction to TensorFlow. So now, okay. So now I will move to TensorFlow. So what is TensorFlow? All right. TensorFlow is a, so you can refer to the module number 2. So what is TensorFlow? TensorFlow is essentially a library, a Python library that is used for machine learning. So, what platform are we going to use to develop our our model throughout this workshop? We will be using something called as Google Collaboratory. So, Google Collaboratory. So, a bit introduction for Google Collaboratory is that it is a platform for. It is kind of like Jupyter Notebook. If you know what Jupyter Notebook is, it is mainly used for training AI models because it has access to GPUs, to cloud hardware such as GPUs and CPUs. So basically, we do not use that training a model requires intensive resources. So rather than we use our local machine, right, so basic that is what Google Colab is. So we move on towards TensorFlow. So TensorFlow, we just touch on the basics of TensorFlow. So what is a tensor and how do you use TensorFlow for things, for learning, etc. So first of all, TensorFlow, it is a library, so you can install it on your local machine if you want. But if you use Google Collaboratory, TensorFlow is already pre-installed within Google Colab. So planning to install TensorFlow within your system, just use just use pip, which is pip install TensorFlow. All right. So first, let us start with importing TensorFlow into Google Colab, which is just as simple as this: import TensorFlow STF. This version, this line up here, TensorFlow version 2.8, because we are going to use TensorFlow 2.0. So for Google Collaboratory, this one is not what is it not this is not required, because for Google Colab, the TensorFlow version is already version 2.0. But if you're using like other notebooks, it is recommended to have this TensorFlow version 2.x. So first we import TensorFlow as TF. So this is like the standard importing the importing name for TensorFlow, which is TF. All right. So after we have imported successfully TensorFlow, so now we are going to introduce a bit of um, a bit of the terminologies and the use of TensorFlow. So first we need to so before we create an AI or model, we first must understand what is a tensor. Okay, a tensor is um so what is a tensor? Tensor is just what I no just for me no for me is what people have the generalization of what tensor is. Tensor is actually a n-dimensional array. That is like the simplest definition I can give to what a tensor is. It is just an n-dimensional array. So if you have a zero-dimensional array, like that is what we call a scalar or rank zero tensor. So if you have a normal array, like an array with, so if you create something like this, so if you have something like scalar is equal to 2. So this is what we call as a scalar, or in the lingo as a zero dimensional tensor, because it has zero dimensions, which means it only holds one value. So another another type of tensors we have something that is called as the um, vector. So vector is basically a one-dimensional array or one-dimensional tensor or a rank one tensor. So the gist of it, a TensorFlow works on these kind of values. So why use tensor? Why don't we just use a normal kind of normal array? So the so because its tensor is how do I say it? Tensor is optimized for computing, meaning that using tensors it actually helps with the calculation. Tensors have a much faster calculation compared to normal arrays. And we have matrix. Matrix is basically a two-dimensional tensor, which is, so a matrix is kind of like this, 3 and 4, and then there's matrix is like this, and there's the further dimensions we have. Uh, so we have things like a 4D tensor, a rank 4 tensor. So we have a rank 4 tensor. A rank 4 tensor is basically a four-dimensional tensor. So we have uh, a four dimension. You have a rank 3 tensor. Sorry, a 3D array or a 3D tensor. So it will have 3 dimensions in the tensor. So so we can look at the example over here. So you have a rank 1 tensor. So this is a rank 1 tensor is stored in an array. So we how about this? We have a rank 2 tensor. It is stored within an array within an array. So there's a 2D array over here. So this is a rank 2 tensor. So why is it important for we need to know all of these things? Because firstly, each model, no, each data that we want to train a model of, it depends on what kind of data it is. So for example, if we have an image is essentially a rank 3 tensor, or what we call as a 3D tensor. Why? Because an image, imagine an image, there is an height and there is the width, but there is also the color channels RGB. So essentially, an image is a 3D tensor. So what about a video? A video is a 4D tensor. So why is it 4D? There's a height, there is the width, there is the color channels, and there are the frame rates. And also there would be an additional batch, meaning that one video, how many image. So it can be a 5-dimensional tensor as well. So that is kind of the basics of TensorFlow. It works on the concept of tensors. So this I will not touch much on this module, but this module we will learn throughout we creating our own AI model. So for now, any questions?
Yes, please.
I'm sorry, is that a question? So far so good. All right. All right. So first, before we move on to module number 3, So let us get like clear our heads first, because it seems like there's bunch of information coming at once. There's the neural networks part, there's the tensor part. So some of you might kind of be overwhelmed with the inputs currently. So let us just take a moment before we start on the module number three. All right. So what we'll be do in module number three is basically we have images, and we want our own AI model to be able to recognize the images that we input. All right. So are you guys ready for module number three? This is the exciting part. The boring part, the theory is already done. So now we are going to move on to the exciting part, to the hands-on part. So I would like for everyone to be ready with their Google Collaboratory. So if you have not ready, so let's be ready with our Google Collab. So I will start with again a web an empty an empty note. So we will do this together. All right. So now let us start module number three. So and the first thing we need to do before we start our image recognition using TensorFlow, every um, we need to import the basic libraries and modules needed for our machine learning model. So obviously, the first thing we need to import is TensorFlow. Import TensorFlow as TF, and we need to input two more helper libraries so that it will complement TensorFlow, which is
Sorry for interrupting, but are you sharing your screen right now?
oh, all right, sorry, wait, okay,
All right, okay.
all right. Before that, can I use TensorFlow for text classification? Yes, TensorFlow for text classification. For text classification, you can use it. Just the input would be text. Okay, but for now, we are using TensorFlow for image classification and image recognition. So basically, the underlying mechanism is still the same. What differ is the shape of the input, what kind of input you want. Okay. So I hope this clears your question about TensorFlow for text classification. There are lots of examples you can find online, especially in TensorFlow's documentation, TensorFlow's guide. There is a guide for how to use TensorFlow for text classification. All right. So without further ado, if there's no more questions, let us continue back with our image recognition. So first, we import TensorFlow, and then we import two more additional libraries to help or complement with TensorFlow, which is the NumPy library and also the matplotlib. SPLT. So why do we need these three? Why don't we just use TensorFlow as a whole? Because number one, TensorFlow works with tensors, and to work with tensors, we need arrays. And as you all know, Python doesn't have technically Python has arrays, but it is not a array in the technical sense. It is a list. So we use NumPy as a way for. All right. Okay. Thank you for that. Okay, so we use NumPy to have access to np.raise, as well as other functions like argmax, which is used for the recognition and the classification part. And and matplotlib, why do we use it? We use it for to plot to show images, to plot images, as well as to plot our ML the learning curve of our model. We will get into why we need to do it later. So if we have these three, then it is safe to import all of the three libraries over here. And then to run the code, just basically just click the button over here. All right. So Google Colab is first it is connecting to the server, okay, and then it imports all of it. This is successful. All right. So now, so what do we do after this? So first of all, we need to we need to know what we are going to make. So for this workshop, we are going to make a digit recognition. So we have the numbers of like 1, 2, 3, 4, 5 until 0, 1 to 9, and 0 to 9. So what we are going to do, we are going to do a machine learning model that recognize the numbers. So if we write like 3, it will recognize it as a 3. So how do we do this? So remember, we are doing supervised learning, so we need an input and an output. We need to have an input or an output, or we call it as a feature. A feature is an input, and labels. Labels what we call as output. So first, we need something called as a data set. So what is a data set? Data set is basically um, a like collection of features and labels for the AI to train on. So this collection sometimes ranges like 5,000 or 10,000 data or files. So the AI will be trained on. So luckily for TensorFlow, we do not need to import any external data sets because within TensorFlow there is already a data set available. We are going to use something that is called the MNIST data set. The MNIST data set, it is a data set of numbers, handwritten digits from 0 to 9. All right. So first, how do we import the data set? How do we load the data set? So we need to load it within something. So I will call my variable mnist is equal to tf.keras dot data sets dot mnist. So this is what we use to load our data set. So we will be using tf.keras a lot because that is what our AI will be trained on, the library that we'll be using. So if you have then this is just loading the data set. It is just loading data set. There in a data set there are two kinds of data. There is the training data and the validation data. The training data is what the AI will study, like we call as study, like train on, and the validation data is what the AI will be tested on. All right. So after loading, we need to essentially split the data set. So within tf.keras, within the data set, it is very easy to split the data set, but within external data set, you need to read their documentation on how to split the data set. This is what TensorFlow uses to split the data set. So we split it into two. The first one is image train and image labels. Image train and label train. Sorry. Oh, label train. So this is the first one. We split it. Okay, next we have image test, image test, and then labels test. It would n equals to mnist dot load data. So what does this do? It takes the data in MNIST, it will split into two groups. The first one for training and the second one for testing. So for the training, it will be split into the images and the labels, meaning this is the inputs and this is the outputs, like what the input is and what the output is. And for the test, the testing data, there is also image test and the labels test, what is inputted and what is outputted. All right, so let's run the cell over here, and then it will download the data from MNIST from the data set. All right, so our data is fully loaded, and now, so before we need to check something first, we need to check what we call as the shape of the image. So what is the shape of the image? So this is what we need to understand first before we start feeding our data sets into the AI model. So image test the shape meaning, so I would take image test. So the image test comprises of 10,000 data with 28 by 28 size. So so essentially the so what there is in the image test, we have 10,000 images with 28 by 28 size. So we can actually change this. We want to check for image train. We have 60,000 images, training images with 28 by 28 resolution. Is it a 50-50 split? No, it is not a 50-50 split because in the like the red what do you call it? The prepared data set by MNIST by TensorFlow, it is already pre-splitted into training and test, because in other kinds of data sets, like sometimes for public data sets, there are where there are times that you need to split the training and the test manually using validation split. But in the case of the tf.keras MNIST data tf TensorFlow MNIST data set, the image and the test are already split. So that's why you can see for the image train there are 60,000 images. Meanwhile, for image tests, there are only 10,000 images because it is already split by TensorFlow. TensorFlow already determined which one is the training image, which one is the testing image. So I hope that clears the question. So no, it is not a 50-50 split. But if you use external data sets, there are some data set that there are some data set that do not have the split, and you need to split the data set manually. So, all right. So for now, all right. So now we have already splitted. We have splitted. We have changed the image and the image test, everything. Now, how about we do something? We do something. How about we try printing one of these? Because this, because what? Because what? Because image train is essentially stored in the form of a tensor or form of an array. So technically, you can print it. So, but it will show up like this. So you can see each image is represented as a one element in an array. So if I want to access the first image for the training data set, so I would do like image train 0. So this is like the array for the first data set, which is not very useful because you cannot read what does this mean actually. So that is why we will show image using matplotlib. So we will use plt.imshow. What image do you want to show? So let me take the first training image, and make it so that CMap is gray. Image train. Sorry for that. So image train and plt.imshow. So oh shit. Sorry for that. plt.show. So this is our first training image. So you can see it is a 28 by 28 image with only two channels, with only one channel, which is a black and white color, which is grayscale. All right. Okay, good rule of thumb is usually 80-20. We need more training data than validation. Okay, that is correct, because because we need more training data than validation data. We do not want it as 50-50. We want it to have more training data than testing data. So you can actually see it over here. So we have image train. There's like 60,000 image train, and there is the 10,000 image train. So normally developers will use the 80-20 rule, meaning 80 for for training data and 20 for testing data. So this is like a preview of our data, of our what we will be training our machine learning model on. So we can see each. So this is image train 1, image train, the third image train. So this is the fourth one over here. So we can see it. All right. So now, before we start building our model, there is something that we need to do first. That is what we call as a data pre-processing, meaning that before we feed our model, we train our model, we need to do some pre-processing. Why is it essential that we do pre-processing? So that there will so that the our model will take lot less time to learn. Because all right, so what I mean is, so if we print our image train here, image train 0, you can see the arrays are like 0, and then it bumps up into like 255 maximum. So this represents the color of the pixels. So if we have over here like a black pixel, it will be represented as 0, and then a white pixel will be represented as 255. So the range is quite big, because it is from 0 until 255, which will take a longer time to compute. So what I do most of the time is I would normalize the image, so that it will be between only 0 and 1, both for the image train and image test. So we will normalize this first. So we normalize, and then we can try look at one of the data. So we can see that it is normalized so between 0 and 1. So 1 is for white, and then 0 is for black. So, and the other one is like the in betweens. All right. Okay. So for now, do you guys have any question regarding loading the data or pre-processing the data? Any questions before we start building our actual model? What is CMAP? CMAP is basically meaning color map. All right. So if I do not have this color map, because Matplotlib's color map is different from what we are used to. This is Matplotlib's color map, which is 0 represents a purple, and 1 represents yellow. So you do not want that, because sometimes it will be confusing. So color map basically just change what color is 0 and what color is 255. Essentially, that is like the simplest definition I can think of for CMAP. So if we have CMAP gray, meaning we are mapping the color as 0 as black and 255 as white. So it will be like this. There are other CMAPs available for Matplotlib, but you can search it up for all of the CMAPs available. There are there are great there are other CMAPs. All right. So that is what CMAPs is. It's basically just changing the color form, not color format, it's like the color mapping for the output. All right. So any other questions? All right. So if there's no more question, I will move on towards building the model now. We can build our first AI model, building the model. Yes, I'm gonna like a section over here and building the model. So building the model, we need to remember the architecture for a regular common neural networks architecture. We have 3 layers. We have the first layer, which is the input layer, the second layer, which is the hidden layer, and last one, which is the output layer. So we will be building the model based on that architecture. So how do we build a model? Using TensorFlow, it is very simple. Let's do this. Keras.sequential. What does sequential mean? Sequential means that the data moves from sequentially from left to right, meaning starting for the input layer, then goes to the hidden layer, and then finally goes out the output layer. That is what sequential means. So essentially, from our architecture, we need to have 3 layers, right? First, we need to have the input layer over here, and then we need to move it into the hidden layer, and then we need to move it to the output layer. So that is what we will be putting in our sequential model over here. So let us start with the input layer. So we can use tf.keras.layers.flatten. So what does flatten mean? So flatten means that it will take a 2D array and it will flatten it into a 1D array. So essentially, we have this 2D, we have uh, this height, and we have width over here. This is our data. So it will flatten the image so that it will be represented in only one dimensional array. So for this, we need to specify our input shape. So what inputs it will be accepting is a 28 by 28 image. You can also add a 1 over here, meaning the channel will have black and white. If it's an RGB image, you can put it over here as 3. So for the sake of simplicity, because our shape is only 28 by 28, you can see over here, our image is essentially just 28 by 28. So for simplicity, we can just put input shape just 28 by 28. You can confirm this over here. So each individual image has a shape of 28, 28. So the input shape tf.keras.layers.flatten input shape equals to 28 by 28. So that is our first layer, our input layer done. Right. Next is we move on to our hidden layer. So what will we put on our hidden layer? Hidden layer is basically what we call it a dense layer. So most things inside a dense layer is basically, what does a dense layer mean? A dense layer means that the layers, the neurons within that layer is fully connected to every neuron before the layers before. It is a fully connected layer. So what kind of parameters are we going to put in here? The first one is how many neurons you want in your model. So for my model here, I will put 128, but you can put any number. You can put like 200 and 256. The general rule of thumb is do it in increments of um, in exponentials of 2 to the power of n. So do it like 64, 128, 256, and etc. So do it like that. It is not it is not mandatory to do it, but it is a great rule of thumb to do it. So, but you need to understand, the more neurons the model have, meaning the longer time it will take to train the model. So you need to find, so this mostly relies on something somewhat of a trial and error. You find the sweetest spot in not too much neuron and not too little neurons. So and the next one we will put an activation function. So what is an activation function? I haven't touched on activation functions. Activation functions basically, that activation function, I would define it in terms of what it does. So what does an activation function do? It introduces something called as non-linearity. Activation. So if we do not have this activation function, essentially our model is just computing only linear values. So it is not good because most like datas or classifications you are done in a very non-linear way. So we how do you introduce some non-linearity so that our model doesn't do something very doesn't train very linearly? We use an activation function. That is one of the uses of an activation function, and what it does is basically uh, it it checks it puts the input of a neuron into an activation function, and then the output will be what the activation function outputs out. So for ReLU, which stands for rectified linear unit, it means that it will only output values of positive values, If it's a negative value, it will output 0. That is a simple definition of what a ReLU is. So there are many types of activation. There are sigmoid functions, there are tanh functions, but for this, to keep it simple, we just use ReLU. And also ReLU is also the most common activation function that people use. Okay, and lastly, so for the hidden layer is done, and lastly for the output layer. So for output layer, so remember our architecture just now we did on the beginning of the workshop. We did there is a layer. So technically this will be also a dense layer. Why? Because it is fully connected. But the number of neurons here, we are going to only have 10 neurons. Why do we need 10 neurons? So our model will be training to recognize digits from 0 to 9. So uh, how many digits are there? There's 0 to 9, so there are a total of 10 digits. So there will be 10 outputs for the AI to choose from. So that's why we have 10 neurons at the output layer. So for this one, we still have an activation function, but we have a different activation function that is called as softmax. So what's the difference between softmax and ReLU? Softmax is an activation function that returns out probability. So what this does is we input a image and then it will output 10 predictions for the image, each with their own probability. So it will predict, oh, this is probably a 2 with like 70% confidence. This is probably a 3 with 50% confidence, things like that. So how do we know what the outputs that the AI is giving? We check what's the highest confidence. So now our model is already done. We can, but we need to do another thing, which is compiling the model. The architecture of the model is already done, but next we need to first compile the model. So what do we, so why do we need to compile the model? So we need to define what optimizer are there and what loss functions are we trying and what metrics are we looking for. All right. So let us go through one by one. The first one is the optimizer. Optimizer is basically the algorithm that we use for gradient descent or for the back propagation part. The back propagation. So what does it? So what kind of algorithm that we use to fine tune? There are lots of activation functions. Is there any guidelines to choose the most suitable? Um, for now, okay. So basically, all right. That okay, yes, there is a guideline. For example, like ReLU, that what we use right now, which is rectified linear unit. This is like kind of like the default one that we use for deep neural networks, right? But sometimes ReLU can be very problematic in case of this is the term where we train and then some of our neurons die, meaning that in the hidden layer, like most of our neurons does not output a does not activate because of ReLU. So we use something as that we call as leaky ReLU. And also for the output layers, we use a softmax because we want the output to be to be a probability, to be a distribution. We do not want it to be binary. We want it to be a distribution. So that's why we use softmax as our activation function for the output layer. So how about things like sigmoid or tanh? Um, it is still used, but the cons outweighs the pros. Like it suffers from vanishing gradients, which makes it hard to train off sigmoid and tanh. So that's why people normally use ReLU. But you can find out like other models online. You can see what kind of activation function they use, but the default one is ReLU, rectified linear unit. All right. So continuing on to compiling our model, so we have an optimizer. Okay, this is what you need to know for now. because I don't want to go very deep on what each of this does, but you can search on what is an optimizer. Okay, so what is the optimizer we are going to use, which is called Adam optimizer, and what kind of loss? What are the loss functions, which is sparse categorical cross entropy. So for these two, just remember for introductory level, just do this. This is like kind of like the default setting. And metrics accuracy. So metrics is basically what we are trying to look for in our model, what we are trying to measure. We are trying to measure the accuracy of our model. All right. So after we have compiled and built, now we can do something like this summary, so that we can look a bit of detail on our model. So this is our model. We have three layers. We have the input layer, the hidden layer, and finally the output layer. So you can see the input layer takes in a shape 784, a 2D array that is already flattened into a 1D array of length 784, and then put into the dense layer of 128 neurons, and output a 10 output outputs at the output layer of 10 neurons. All right. So now comes to the part where we can now finally our model. So we can train our model using model.fit, but what I would like to do is put this into a variable. Why? Because we can track our history, our models punya history. All right. So what kind of inputs, what kind of parameters we must have in here? We first have the training, the training data, which is image train, the labels data, the labels data, the training labels, I'm sorry. And also we want some form of validation for our model, so it can check how it's doing. So we put in validation data. So validation data is equal to uh, basically image tests and also labels tests. And lastly, epochs. So what is epochs? Epochs is basically how long, how many times your model is going to be trained. So I will, for the sake of simplicity, I will only put 10 over here. So meaning our model will be trained 10 times. So we can run our model here. So it is going to start learning. This is the metrics. There is accuracy and as well. So this is the time where I explain what accuracy is and what loss is. So what accuracy means is, um, accuracy is a measure of how much how much your model got the training data right. Meaning basically like there are how many rights versus how many wrongs. That is the accuracy. How about loss? Loss got to do with the confidence level uh, of a model, because the output is a probability, meaning that for a certain image there will be like the output 0 have like 20%, output number 1 have like 10%, output number 3 have 30%. So the loss is basically based on each of this confidence value. So the sometimes you can see that the accuracy is low, and the accuracy is low but the loss is high, meaning it is confident but it is wrong. If you see accuracy high but the loss is also high, it means that it is right, but it is not confident with its answer. That is like the general, how do you understand? So if you have an accuracy that is high and then a low loss, meaning that it is right and it is confidence with with its training. So now we have at epoch number 9. All right, and we will be finding. So you can see how our training model improves over time. So we start at like 88% accuracy, 0.88, And by epoch number 9, we are at 99% accuracy on training tests. All right. So after we have trained this, we want to analyze it first. So for analyzing, it is very hard to analyze it in this form. That's why to analyze it, we are analyzing it in the form of graphical form. So first we need to form a what do you call it, a matplotlib. We need to plot it. So plt.plot. So plt.plot, first we need to plot the fit. So training, right? So our model, which is training dot history. So what metrics are you looking for? So for analyzing a model, we typically use the loss metric to analyze our model. So plot our model. So for this, I'm going to give a color of red and label it as loss. All right. So there's this, and then we have validation loss. So we want to compare the loss and the validation loss. Why? Let us get that into a minute. And then plt.xlabel, we label it as epoch, and plt.ylabel, we plt.ylabel, ylabel loss, and plt.legend, then plt.show. All right. Can you see that? Okay. All right. So this is what we use to analyze our model. So when we run this, we can see this is our model. Right. This is a validation loss. Right. Sorry about that. Okay, validation loss. All right. So this is what our model's validation loss is looking. So how do we analyze this? So first we look at the red one, which is the training loss. The training loss decreases steadily, meaning that over time it becomes more and more confident. But the problem is with our validation loss. So what is happening with our validation loss here is that the validation loss is kind of like fluctuating, and it is firstly it is steadily decreasing, but at one point it stopped decreasing altogether. It only decreased by a small amount. So this is a problem that we define as overfitting. So what is overfitting? Overfitting in simple terms is the AI doesn't learn, it remembers. So uh, are kind of like humans, but if we learn too much at a certain point, we tend to memorize things rather than learning things. So this is what happened. Uh, so this is what happens when AI. So that it is overfitting, meaning it starts to remember more. It starts to remember rather than learning or making a generalization. Should we put an early stopping at a root? Yes, you can put an early stopping, but again, if you put an early stopping, your accuracy will be only like 96, 97. So in the case of MNIST, we take it as like a very we can take it as like a good enough. So but there are other ways to circumvent overfitting rather than like stopping at like epoch number 2. So at the point where it started to overfit, we can stop at that, but there are two other ways. First way is to do data augmentation. The second way is to do something that is called dropout. So this one I would like to implement dropout. So now to overcome some of the overfitting, we are doing something called as a dropout. So what is a dropout? A dropout basically means that in your model, in each iteration, So we will need to modify this so that it will to include dropouts. So dropouts meaning that we have certain neurons that we deactivate. So why do we want to deactivate that neuron? So that the AI must come with more generalized solution. So how do we implement dropout? Which is very simple. We just put it before the dense layer, after each dense layer. Sorry, after or before. So we put it after each dense layer. So for this case, I would put it after this one, and then TF the layers drop out. So I would put like zero point 0.2, meaning that the zero point 0.2 dropout, meaning when training, it will drop 20% of its neuron. But then again, I want to like have it to become more again, I want to add more layers to it. This is there's no set of rules. It is more towards like trial and error. You must find how many neurons is just enough, how many dropout rates is enough. So now it's just like a matter of you testing and tweaking individual values. So now we have our new and improved model with dropout. So we can retrain our model. Just add I added for me I added two dense layers, two hidden layers, and then each of it has a dropout function. So and then I will train our my model again, so we can analyze our can you paste here the code for plotting the graph? All right, I'm sorry. Okay, this is for plotting the graph. Okay, this is for plotting the graph. So it is learning. As you can see, it is compared to the first one, it is kind of slow. So this is having a 30 sec. It is kind of certain parts of it taking a longer time. It's because I have an extra layer of neuron. So if you have more neurons, it will become the training process will be it take a longer time. So so for you can do it like epochs 5, but again, epochs mean how many times you want to training. So training an AM already takes a lot, very long time. So we cannot do anything. We can just be patient with it. So this now, so as of epoch number 4, we have an accuracy of 96, 97. All right, it is decreasing steadily. All right. So we can actually have a very analysis over here. It started with 0.5 loss, but it the loss is steadily decreasing. So how about this? The loss is also steadily decreasing. So compared to, you can see compared to over here, the loss kind of like stagnated over here and started to bump up. It is fluctuating between a single value. So how about this? It is there are still fluctuations, but after it has finished training, we can see it on the graph. You can see it on the graph to analyze and compare our models before the dropout and after the dropout. All right. Now it started steadily increase. Damn. All right. It seems that our okay. So how about we plot the graph here? All right. Again, there seems to be some kind of overfitting over here, but compared to what we have and what we have before and what we have now, it seems to be better because it started its validation loss with a very low number. Compared to here, we have a very high loss number in the validation, and it started to fluctuate less. Okay, if it's like steadily increasing, it is okay, but there is still signs of overfitting, but it is better than the fluctuating loss over here. So overall, this is a better model because this has less overfitting issues. So now it is a matter of tweaking. So you can do on your own. You can tweak each of these. You can add neurons. You can decrease the dropout, or you can increase the dropout. So it is a matter of tweaking the values until you get the right one. All right. So another one compared to compared to on this the our model before, if you want, there's another way you can stop overfitting. You can stop when it is start around the point where it converges to prevent overfitting. So when you see it started overfitting at around 2 blocks over here, and our current model, the latest one, it started overfitting over here. So it started overfitting more later compared to our earlier models. So you can see how our model has improved. All right. So so we so for my validation loss, it decreased, then increased again, then decrease again after adding dropout. Is this normal? Yes, it's normal because you cannot get it perfect for the first time. So what so that is a sign of fluctuation. So what you need to do is essentially tweak the numbers until you get you settle down on a result where you are satisfied with, right? It is totally normal because all right. So now so for this, let us settle with this. This is good enough for me. So if you want to continue, so now we want to continue on training on our own model. I mean, so our model is technically done over here. So now we want to do something that is very fun, which is we want to try and input our own, like, does learning rate affect the loss? Does learning rate affect the loss? Yes. Okay, in a sense, learning rate can affect the loss because learning learning rate, yes, if how do I explain this? I A simple answer is learning rate, yes, it affects the loss. um, but learning rates cannot be too high or even too low. It must be optimal because if you have a high learning rate, means that it will result in a fluctuating loss because it is learning too fast. That for if you have a learning rate, you have a low learning rate, uh, it the loss decrease steadily, very slowly, but the training will take forever. And if so, you need to find a very optimal learning rate for your model. Now we'll do something. We want to try to upload our own image, and we want the AI to recognize the image. All right. So what can you do is you can do this. This is what I like to do. This is what I like to do. Okay. You can oh my god. You can boot up Paint. Can open up Paint. So Paint over here. You can open up. You can have a 28 by 28. Can have some image. Can have a 28 by 28 image. Can have something like this, 28 by 28 image, and then make the background a bit make background black, and then you can write the number you want over here. So for example, I want to write a number. For example, I want to write the number 5, right? And then I would like to have my model identify what have I written. So I write this as a 6. So I will save this. I save this for example on my desktop 6.png 6.png, and I would import this from the desktop. Where is my 6.png? This is 6.png, and I will import it over here. Now I would like to load the image. So how do I load the image? It's very simple. We um, can use okay. So we need to first specify the image path, which is equals to 4.png, 4.png, sorry, 6.png, and then image is equal to tf.io, the read file, image path, and then image is equal have the image decode. Wait, is it? No, tak ada, right. And then image, go to tf.image.resize, image, resize it into 28 by 28, and then process the image to have it to normalize the value. Then image equal to tf dot, okay, I will explain this part. Then image axis equal to 0, and lastly we'll try to print the image shape. Okay, this part is not decode png, sorry, but so image and then channels to 1. The images is not different. Oh, sorry. Image. Oh, damn. All right. So basically, this is how do I load an image to be fed into a neural network. So what this part does, this is like the most unintuitive part, expand DIMS, because TensorFlow expects you to have an input. Do I need to remember all of the syntax? No, it is not. You don't have to. You can just implement it lots of other ways, but this is how I implement this syntax. All right, so for this one, TF the expand divs. Basically, TensorFlow, the model expects you to hand in a batch of image, not the single image. So that is why we need to expand the divs, which we must tell the model, okay, this is an image, but it is in a batch size of 1. So if you have like many image, this will be like batch size of 2 or 3. So this is like how TensorFlow works. It works with image in batches. It works with batches. Expand, so they include the batch size of 1. All right, so after we have run this, we have successfully loaded our image, and now let's try input our image into here. All right, so we can do plt.imshow, can put in this one, tl.file to read, can copy. All right, this is to this, so we can use tf dot. So we so erase the resize. Okay, so before that, I would like to do this before the resize image prediction, because we want to predict this prediction. I'm going to change it to image prediction. Go here, then run this image prediction image shape, then prediction. All right, and then over here TF, and then plt.im show image. Okay, it will show this. Then to make it better, cmap is equal to gray. All right, and then plt.show. So how we basically do make it so that our model can predict. So so we can do prediction is equal to model dot predict. This is simple. Predict image prediction. So this basically we want to the point after we have expanded the dimensions, we need to input this. We need to input the image prediction over here into here. So we can print out what prediction it has, what prediction it is giving for this, but wait, print prediction. Prediction model that predict. Oh, all right. So it is outputting. Okay, this is a very good one because it is outputting like this, but we want to have a very we want to have we do not want this kind of output. We want output of a singular number, so we can use np.argmax. So what does np.argmax does is essentially just gives out which one of our inputs that has the highest confidence value. So when we output, it successfully predict that our number here is a 6. So you can try and test with different, you can use paint, you can use paint to write some numbers and you can load it and try different writings to predict. All right. So that is all for module number 3. So before we move on to module number 4, let us have a small break. And if you have any questions, just write it down in the chat. I will try my best to answer your questions. So let us take a short break before moving on to module number 4. All right. Where did you download the app for this workshop? We do not. We only use the web application, which is Google. We can search for Google app here. Can you show the code for argmax again? All right. So wait. The code for argmax, which is very simple, is np.argmax. How can it integrate with front end or back end? All right. That is another topic. But essentially, what you can do, TensorFlow have TensorFlow has something called as a TensorFlow API, where you can integrate TensorFlow with the back end. So you do a call towards the TensorFlow API. You can do a model because the model can be downloaded and integrate the model within your code. There's a lot of it in the documentation. So I suggest documentation. If you want to cover all of it in this workshop, is not there's not enough time. Can I have the image path code? Oh, image path code part there. All right. All right. So, all right. So let's module number 4. But before that, there's someone asking a question: how to determine the number of neurons to use? All right. So that is basically up to you. There is no set rules of what number of neurons to use. It generally comes down to your tweaking. How do you tweak your model to have? So, for example, if the learning rate if it's still not that accurate, you can increase the number of neurons you want. You can decrease. It is a matter of tweaking, right? It's kind of like trial and error, but kind of like trial and error. So number of neuron is basically up to you. There is no set of rules, so you just tweak until you find the right one, right? So does that answers your question? All right. So this one, I would like to go on like a bit kind of fast because this one uses that we had learned before, just implements it in another way. So now we move on to module number 4, which is image classifications using CNN. So what does CNN stand for? It's for convolutional neural networks. So our first model before, it is called a MLP. The another name would be a feed forward network or a dense layer. Another name for it would be an MLP, which is a multi-perceptrons. So our MLP before this has many issues because it is very limited for image classifications. Why? Because it can only handle small amounts of input data. It struggles with larger and larger data, and also multi-layer perceptron, they do not have any sense of feature recognition or recognizing feature and spatial recognition. Why? Because before you put the uh, uh, before you input it, you need to flatten the image. Essentially, from a 2D image, you change it into a 1D array. So all of the spatial information has lost. So they cannot understand. So the MLP struggles with things that require spatial information. So that is where convolutional neural networks come in. So first we need to understand what is convolution. What is a convolution? Convolution is basically an operation, is a math operation that extract features. Right? Uh, so I would demonstrate. A demonstration is a way to understand what convolution. You don't need to write this code. This is just a code for demonstration what a convolution does. So for example, I have I have here a number 3. So I uploaded a number 3 using the MNIST dataset. So I apply some sort of convolution to the number 3 to detect features that the number 3 has. So first let's wait for it to import. So here, and then if I run the convolution algorithm, what it will output this. So it will essentially detect features of a certain image. So for this, it detects it has edges like this. It uses something that we call as filters. So if I change my filter for a vertical edge filter over here, so it will detect the vertical edges. So it will detect vertical that are present in the image. So and then after it detected using convolutions, it will go into another part called as pooling. So pooling basically just reduces the number of pixels overall to have a smaller input to be fed into the neural network. So it will essentially reduce our image from this into this. It's called a feature map. So rather than recognizing images from pixels alone, we recognize it based on features that it has. So you can see this in action. So it will have this. So that is basically what convolutional neural network does. It is same as the MLP, the multi-layer perceptron, but before all of this, there will be another layer on top called as the convolutional layer. So I will not, okay, so you can refer to the module, but for now, because we do not have much time after this, so we will just use what we have here, and then we will modify it so that it has a convolutional. You can add a convolutional layer over at the top over here. All right, so how do we make a convolutional neural network? So most of the parts are the same. So in the module I have given in the link, it is using another data set. So this data set is actually a data set um, that is more advanced compared to the MNIST data set, because it has images of airplane, automobile, bird, things like vehicles and animals. All right, but for the sake of today, we are just gonna continue using the MS data set. And then, how do we do the model? Again, most of the steps are relatively the same. So except our model will now have two different layers and have more sub layers. So the first two main layers here we have, which is called the feature extraction layer. This is where the convolution layer sits in. So the feature extraction layer, this is the convolution layer. So we have the convolution, and then we do max pooling, and then do another convolution, max pooling, and then do another convolution. So I will explain each parameter and what does it do. All right. So so we add it by tf.chara the layers.convolutional 2D. So in fact, I will put, okay, okay, so how do we improvise this? We put it on top. All right, so now the flatten will lose its input shape. We will remove the input shape because it is no longer the input layer, because the input layer is the first convolutional layer. So first tf.keras layers dot convolutional 2D convolution 2D, and then 32 by first the first parameter here is 32, meaning how many filters we want to use, or in simple terms, how many features we want to detect. So I want to detect like 32 features. Like, it seems like overkill, but for the sake of it, like, just imagine we have 32 filters. Okay, next is our kernel size. What is a kernel in convolution? So when convolution, there is something that we call as a kernel. This is a kernel, basically the size of our filter. This filter will stride along. Um, how does it do? It will take, in this case, it will take a group of 3 by 3 pixels. It will multiply it and add them together to get our filter. That is how convolution works. The standard like size for a kernel is 3 by 3, but you can improve it. You can be it to a 5 by 5 or a 7 by 7. All right, 32 and 3 by 3. And then um, remember, this is the first layer. So when it is the first layer, we must have an input. We must have, what we call it, as an input shape. We must determine what the input shape will be. The input here is input shape is in this case is 28 by 28. That's the same. Okay, and also I forgot, we need to also have an activation function for here, which we're going to use ReLU. All right, so that is our first convolution layer done. Next, after convolution, remember after we have done convolution, we move on to pooling. So pooling, basically, what is pooling? Pooling basically it takes in a group of pixels, and then it outputs the most. There are max pooling. We are going to use max pooling. It will output the pixel with the highest value. So it will show the more prominent features inside of an image. So how do we implement this? Simple. This is just tf.keras dot layers dot max pooling to D, and then the size of our group we want to have, which is 2 by 2. So that is essentially that is all we that is the modification we need to add in order for our model to become a convolution model. All right. So now our model has become a CNN model. It is no longer an ML3 model because we have the first layer up here, which is called as the feature extraction layer or feature extraction layer or a convolutional layer. And the second one we have over here, which is the feed forward network, the dense layer or the multi-layer perceptron. You can name it whatever you like. Essentially, it's just built on top of this. Okay, we can do the same thing. All right. So what is wrong with here? Always 2D when expected dimensions on dimension 3. Save none 28 actually. Oh, all right. We need to have another one, which is 1. What is 1? It specifies what channel it has. All right. Because max pooling layer expects a tensor of rank 4, meaning it wants at least the shape at least 4D, meaning it wants the image to have a batch size, a width, a batch size, width, a height, and also the channel. So that's why when I add one here, it means that it only has one channel because it's only black and white. So before moving on to the max pooling over here. All right. So now we have done our model. It is time for us to train our model. Again, we can use it. Training is equal to model dot train model dot train and right, image test and image train. So image train, as well as labels train, and then wait, I'm sorry about that. So I will just copy this to lazy all. So you can just copy this model fit image train value data. So for now, I will move my epochs to only 5. Why? Because sometimes when you use convolution layer, it takes a lot of time. So 5, 10, I will try to do it in 7 epochs. All right, so it is training. Now, again, it will start with low accuracy because convolution, because it is our AI, our model is training off of new architecture, which is the CNN architecture. Again, so for now, we will wait first for our model to train. So while we wait, do you guys have any questions? You guys can refer to module number 4 for like a whole in-depth tutorial on how to use convolution neural network. So convolution is converting to pixel, not convolution is for detecting features, right? It is not to convert to pixels. It essentially like combines the pixels together, right? That is how convolution works. We have a 3 by 3 kernel and we combine the convolutions. Okay, so I wish, okay, this is like actually how does it do? It will detect features. So when you look at this, how does it do? We have pixels like this. This is a number 3. So what convolution does, before on our earlier model, we will just like input 3 like this and hope that it recognizes as a 3. But it is very inefficient, very not inefficient, it is not that good because we do not want the AI to off the pixel values alone. We want the AI to train based on the features that number 3 has. So we apply convolution, it may look like this. So the AI will know that, oh, for a number tree, it must have these features for it to be classified as a number tree. If it does not have these features, it is not a number tree. So essentially, that is what convolution does. So for numbers, it is very not clear enough. For larger scales, like if you want to detect, for example, if you want to detect whether something is a human or not, or you want to do like facial recognition, like you can detect someone's emotion if someone is happy or sad, if someone is making a happy face, an angry face, or a sad face. You can use convolution because convolutional neural networks will detect features an image has. So that is the plot that so with convolutional neural network is just an addition to what we had done before, so that it can detect what do you call it, the features or prominent features. Again, so you can see how much efficient our model is compared to what we have before. All right, what we have before, it takes what about 8 epochs to get to like 98% accuracy, and for the train for and more than 10 epochs to get more than 98% validation accuracy. But if we use convolutional neural networks, you can see that it actually achieved 98% accuracy on the third epoch, and for the validation accuracy on the first epoch is already 98%. You can see the difference, a convolutional neural network and the multi-layer perceptron. Can I know how do we did so why we need okay, why we need to do pooling? All right, okay, that is correct. Then, so not much pixel is needed to learn. All right, because pooling, essentially we have a 28 by 28. So we want the AI to learn, but not that much. So we use pooling to reduce the number of pixels or inputs we have. So rather than inputting 28 by 28, it will return, in this case, it will have wait, ah, only 5408 compared to before the input for flatten, which is wait, 5408. Where is the part over here? Cannot find it. But okay, it is 13 by 13 because rather than it become 28 by 28, the output shape will be 13 by 13. So essentially, the input will be much smaller compared to um, what we need initially, which is 28 by 28. This is correct. So to achieve optimal performance, we need to make sure the loss and validation loss are close as possible. Yes, kind of. We need to, yes, loss and validation loss close as possible, yes. And also we want it to have a steady decrease, the decrease almost the same. So when we look at our initial model here, we have the loss decrease at a steady rate, but the validation loss is struggling to decrease. So what does this mean? This is mean overfitting. We want both losses to have a steady decrease, like kind of like mirror each other. Okay, can I know how do we determine the number of kernels? This is again is based on tweaking and trial and error, but essentially the default one people normally use 3 by 3, but it depends on your tweaking and your settings. Are the models only able to process numerical data? Will you be able to form predict string? And would they need? All right, this is a good question because this is essentially how chatbots work. Yes, it is only to process numerical data, but how? If you assign a string, for example, if you want to detect like for reviews classification, you want to have an AI to classify which one is a positive review, which one is a bad review. So you assign like certain words, like for bad review, a numerical number for bad review, meaning, for example, you can search for word bad, horrendous, trash, terrible, put it, assign a value like 2 or 1, a weightage system. So like a bad review will be like -2 or -1. So a good review like good, amazing, incredible. We can assign it like +1 and +2, and then um, make and then if you feed in the data set, make sure so that the AI to search for these keywords so that it will replace these keywords with the value numerical value you assign to it. And would it be able to form predictions for strings? All right, this is a more on an advanced topic where essentially it can, but you need to provide it with a list of what possible strings it can output, uh, and then you can use it to make predictions for strings. All right, this is for this part is a very long topic. I suggest you can try look up something that is called as a transformer, which is essentially what most chatbots run in, which is a transformer. You can search up in YouTube or anywhere, search up transformers. The 32 in the parameter for convolution layer is just a number of neurons. No, for the convolutional 2D layer, the 32 here is the amount of filters we have. Like essentially how much features we want to detect. A convolutional layer doesn't have neurons. The neurons are all in the dense layer. This is the feature extraction layer. Okay, and so we can use an example to of and yes, you can also follow that. So the 32 over here is not the number of neurons, rather the number of filters that we want to use for our image. So the 32 meaning there are 32 filters. So our model has done training and we want to plot our graph to see how well our model is doing. You can see again there is, even though it is good, but there is a sign of overfitting here. Why? Because the validation loss is struggling to decrease steadily. It is fluctuating, meaning there is overfitting. Again, how do you overcome overfitting? And use dropouts, and there is another way, but I will go to this other method of countering overfitting very quickly, which is what we call as data augmentation. So what is a data augmentation? So a data augmentation, in essentially what it does is before it inputs a data or an image, it will like adjust the image so that the AI won't see the same image every time it trains. So for example, this is what I do um, for so in this case, the data augmentation is I put in a random zoom layer. So it will zoom the image for a few factors so that the AI will sometimes see an image that is large or an image that is small. So how do you implement data augmentation? Again, it is a keras layers. So you can just take this and then you can just put it at the top before feature extraction and density. You can put it at the very top. And remember that the input shape must be depends on which one is the first layer you're going to have. So you can use data augmentation over here to kind of and combine it with dropout to get a more efficient and more optimal model. So this is what I want to share. This is what I got for for last time over here. This is you can see this is what my convolution new CNN um, got for its loss and validation loss. You can see this is can count as optimal because the validation loss is not struggling much to decrease, um, be it that I run like for 4 and 5 epochs. But then again, the validation loss does not does not deviate too much from the training loss, which means that it is not overfitting over here. So what do you want from a model is a model that the validation loss and loss does not have too much difference. If the loss is steadily decreasing, you want the validation loss to also steadily decreasing. As compared to this, the loss for the training loss is steadily decreasing, but the validation loss is struggling. So this is a sign of overfitting. So that is all. But before that, how do you want to like actually use this model? All right, you can use this model. You can basically uh, save your model using model.save and save it as these two formats. So I will say an MNIST model. We can save it as .h5 or polysave.keras. So if you save it, you see it pop up over here and you can download this file. All right. So before I end, I want to show you like one of the use, what can you use and where you can use the actual model and how to use it. Okay. Okay, so this is like one of can you see my screen over here? Right. So this is one of the implementation of how I use my model. So I basically made a recognition using the MNIST model. So how do I use it? It's very simple. You can just import your TensorFlow, keras or models, import load the model. So you can just go to load model. So what is the name of your model that has been saved? And then what have I done here, which is a very simple Python program that recognizes your handwriting. So after you load model, like the most of the part is just the same. Can just it is like similar on how you train it. All right. Okay. This loading, so it takes the time to load first. How do you use it? Actually, is kind of the same. Platinum NPL max prediction, and you have this 2.8 drawn pad. So we have like I can write number 2 and then it will predicted number 2, and here are the confidence levels like 0. So if I have like 3, it will predict number 3 and the confidence level. This one is very optimized because I've done it. I did multiple tweaking, multiple optimization. This one is kind of fairly optimized in my opinion. But again, you can use okay for this. It struggles between 9. It struggles between 7 and 4, which is fair. And then we have like 9 struggles between right. So that is all. All right. So before we end, do you have any like last questions? Can it integrate with HTML and CSS? Yes, it can integrate. You just but the way to integrate with HTML and CSS is kind of different because we've been using Python to write our um, the Python. You use Python to um, because you use Python to train TensorFlow models. If you want to integrate with HTML and CSS, I suggest you using TensorFlow JS. There is a JavaScript library for TensorFlow JavaScript library. And you share the latest coding with data augmentation. It is the data augmentation is within module number 4. So just refer to module number 4. Okay. Okay. So any other more questions before I end today's workshop? All right, no more questions. So with that, I end for today's workshop. Thank you very much, everyone, for joining.
All right. Thank you. Um, Thank you so much, Ayman Hakimi. I'll share with you guys the feedback form. Please give me a while to share my screen. All right. Okay. Thank you so much, Ayman Hakimi, for guiding us through today's workshop and sharing your expertise on TensorFlow and also neural networks. I hope you guys learned a lot today. If you have any questions about today's module, TensorFlow, or anything related to what we have covered, feel free to ask in our WhatsApp group. Alright? So before we move on, we would love to hear your thoughts on today's workshop. Your feedback is incredibly valuable to us. So it will take only 2 to 3 minutes to complete with this feedback form. You guys can scan it and take your time. I'll give around 2 minutes for you guys to scan and show us your thoughts about today's workshop. All right, so now I would love to invite all of you guys to join us for a photography session. We would love to capture this moment. Okay, so if you're comfortable, please turn on your cameras. We'll give you 3 minutes to get ready and to turn on your camera. for this photography session. Okay, I'm going to stop sharing so that I can get all of you guys in the screen. Alright, okay. Thank you so much. Are there anyone else that would like to turn on their cameras? Okay, I see another new one as well. Alright, okay. Thank you so much, everyone. Okay, so the first one, let's do a formal one. Okay, just smile to the camera. I'll count 1, 2, 3. Alright, everyone ready? 1, 2, 3. Okay, all right. We got one. Let's do another one with our GDG sign, which is like this. We also call it as a gang sign. Yes, raise up your hand. It's like two, keys, but then you do it like this together. Okay, I see a few hands. All right, that is so nice. But I need to, press the record button, so I just do one. Okay, so smile. 1, 2, 3. Okay, one more. All right, let's do last one. Let's do any freestyle. Okay. Okay, everyone ready with your freestyle? 1, 2, 3. All right. Thank you so much for joining us in this photography session. Okay. I have some, exciting things to share again with you, like just how I shared during our introduction just now. So, as you guys know, this workshop, you guys may know or may not know, this workshop is in collaboration with Kita Hack 2025. All right. So, I'm gonna need your attention to a few of some details on Kita Hack 2025. All right, so I hope you guys can see my screen.
All right, so Fatiha just lagged out, so I will do closing. So thank you very much for joining today. Yeah.
All right, okay, I'm back. Sorry for the technical issues. Okay, I see some of you guys are still here, so I'm going to grab this chance to promote Kita Hack. Okay, so this is the registration form. You guys can go to this link right there below or scan this QR. And then the info pack, so you guys can if you want to know more about Kita Hack, just scan this QR code or go to that link. Okay, if you would love to join but you don't have a team, you can join our Discord channel. We do have a Discord channel where you guys can ask around if anyone would love to join your team. Anyone does not have any team members yet, then you guys can form a team, make some friends. All right, so this is the Discord channel. Can take a picture first and or maybe scan right now. Okay, this is the Kita Hack Instagram and also Discord channel again. All right, so we posted most of our updates about the hackathon on our Instagram, so do stay tuned on our Kita Hack Instagram, which is at kitahack.my. All right, so these are the upcoming workshops that we have. So we have 5 workshops for this Kita Hack. The first one, which you guys attended today, is this TensorFlow workshop, and then next week we are going to have Google Workspace with AppScript, and then the other week we are going to have Flutter workshop, and then Google Cloud Platform workshop, and last but not least, we're going to have Vertex AI and RAG workshop. All right, so these details are all in our Instagram, so do follow us there. Okay, so last but not least, thank you so much for joining us today. Have a full day. If you have any questions, do ask in the WhatsApp group. The recording will be shared later. All right, so we'll announce in the WhatsApp group once the recording are done. Okay, thank you so much, everyone. Have a nice day.